Okay, so this is part 4 of the video on weak acid strong base titration. And in this, we are at the point where we've added 50 milliliters of the base. So if we have 50 milliliters of the base, that means, let's see here, this is 50 milliliters of NaOH. It was 0.1 mole per liter. That means we've added 0.005 moles of NaOH. That's exactly the same number of moles of acid that we started with, so this is the equivalence point. So let's think about what that means. That means that in this equation, I started out here 0.005, 0.005, none, and we don't really count that. And so if I set up my ice table here, all of this has been used up, all of this has been used up, so I end up with none of those, and I'm adding 0.005 here. Well, this is the conjugate base of this weak acid. So I'm going to write how that equilibrium would look when it's interacting with water. And so I can see that it's really just the reverse of what I was just doing. But I can set up a nice table of that to analyze what my amounts of each of the species would be. So this, again, I'm not considering. We said that this is 0.005. We're saying that initially there's none of those. And as the equilibrium, adjusts, then there's going to be some amount of this that is lost. So at equilibrium, I'd have that. And there would be that amount gained over on this side. So I can set up an equilibrium expression. Now this is a Kb because I'm setting it up for this base. So HaOH minus over the A minus. And I can put in my values from my chart. But obviously I need to connect this with something. Well, I'm going to make two assumptions right now. I'm going to assume that this is at 25 degrees Celsius and that Ka times Kb equals Kw, and that Kw is 1 times 10 to the minus 14. And I have my Ka, so my Kb is Kw divided by Ka, 1 times 10 to the minus 14 over 1.8 times 10 to the minus 5. And so my Kb is 5.56 times 10 to the minus 10. The second assumption that I'm going to make is that 0.005 minus x is approximately equal to 0.005. So I can put all this information together and say that x squared over 0.005 is equal to 5.56 times 10 to the minus 10. Solving for x, I can get 5.27 times 10 to the minus 6 for x. And that, keep in mind, is the amount of OH minus. What I'm looking for is pH. But I could calculate pOH, which is 5.28. And then keep in mind that pH is going to be 14 minus the pOH. So 14 minus 5.28, and get 8.72 for that. And then go back here and fill that out, 8.72. We're getting there. This is part 4.